Hi, this is Mighty CS Man. I teach a complete curriculum on Java programming using the Building Java Programs book, and they have a free website called Practice It, and I'm going to be showing you how to do self-check 5.13 sentinelMinMax. So as I always do with these problems, I'm going to show you how to do it, but I don't want you to just copy what I'm doing. I really am going to try to show you how to think through this problem, and I really want you to do it on your own. This video is going to take you a lot longer to watch the video than it would be to just do it on your own. So you should try that, and then only when you're having problems, watch this video. So let's talk about, first of all, what the problem is. So they want you to write a sentinel loop. I wish they really hadn't told you that, because I want you to figure it out that it's a sentinel loop. But we're going to have a loop that repeatedly prompts the user for a number, okay, or -1, and displays once we've hit -1, then we're going to display a minimum and a maximum. So there's several things that they're doing here. So as they already gave away, this is a sentinel loop algorithm. And I believe we just have to write bare code. Yes, bare code. It's a sentinel loop algorithm. And if you look at your book in chapter 5.2, it talks about what a sentinel loop algorithm is. Really quickly, let me give you what the algorithm is. So, I'm going to note, first of all, it's a sentinel loop with -1. With -1 as a sentinel value. Okay. The form of the sentinel loop, first we're going to have to do some initialize. Then we are going to prompt and read value into variable, and I'll say initialize variable. Okay. I'll call it a temp variable, because that's what it really is. That's the variable that we're going to use to store all these numbers. So we're going to prompt and read into that value, and then while we haven't hit sentinel value, we're going to call it, let's just say, process the number. And then we're going to, once again, I'm just going to copy this. We're going to prompt and read that value. And that is pretty much the pseudocode for what a sentinel loop is, okay? So we're going to be, the main thing is that while we haven't hit the sentinel value, we're going to keep on doing this. We're going to process the number and read it. Now notice, if you watched my video for 5.12, this is actually a loop and a half solution, okay? So why is it a loop and a half solution? So it's a loop and a half solution because normally the normal order of these operations would be to prompt and then process. Prompt and then process. But instead, we have a problem here. We get this -1 value. So if we did that, we did a prompt and then process, we would end up processing the -1. And we don't actually want to look at number -1 as the first value. So instead what we do is we do the loop and a half solutions. Okay, so if we do the half loop first, which we're going to reverse the order of these things. Instead of doing a prompt and then process, we're going to process and then prompt for the next number. And that means we have to prompt for the first number before we get in the loop. Okay, so this is actually the same as 5.12 in terms of the algorithm for the solution, the loop and a half. We do a half loop here. I'll write that. This is a half loop. And then we're going to do the full loop here. Process, then prompt. Okay. Now we have another complication. We have to figure out what the minimum and the maximum was. Okay. So when we have the process number here, this is where we have to find minimum and maximum. So, so I think what we'll do is let's do the loop, the sentinel loop first, and then we'll work on how to find the minimum and maximum values. Okay, I believe this is bare code. Yes. So we don't have to write any class or method headers. So we've got our sentinel loop with -1 as a sentinel value. Initialize the temp variable. So let's create a variable int input. And half loop prompt and read value into variable. So to do the prompt, we're going to do system.out.print, not lin though. And then let's do this here. And then read the value into a variable. So I'm going to first do that code. So we'll say input equals scanner dot next int. And now I've actually got to create the scanner. So let's put that up at the top here. Okay, so this tells us we're going to create a new scanner on the system input console input. And I've got my input. Okay, now what we got to do is we've got to put a while loop. Oh, yeah, okay, so I need to put the condition here. While we haven't set the sentinel value. So while input doesn't equal -1, then we're going to do this code here. So we're going to skip the process number, and instead we're just going to prompt and read the value into the variable. So this is exactly this same code here. And you may be wondering, isn't that like duplication of code? Yes, it is. And that's why the professional programmers don't generally do this, but it is a very good way to teach things, and it makes it work. So I'm going to go ahead and try to run that. So this is not going to get me the right answer. It's going to fail, but it did at least have the first part correct, right? So the expected output and my output matched up to the point where it's going to print out the minimum maximum. So that's good. Now, also the observant reader may wonder, now, how did it come up with all these numbers? Because weren't we expecting it to ask us? Yes, we were expecting to ask us, but PracticeIt is using a test harness, and PracticeIt is actually providing all these numbers, overriding system in. It's a very clever little program there. But anyways, what we need to do now is process number. Now, you may remember that we've covered this min and max before. In chapter 4.2, cumulative algorithms, they talk about how to do that. And in order to do that, we first have to initialize variables, okay, to either the, we're going to initialize the minimum to either the first or the lowest value, okay? Let me, here, I'll just write that. Oh, it's actually separate one. Initialize min to first or lowest value, and max to first or highest. Okay, so whenever you're doing a min-max, you need to do that. So what we can do is actually assign min, a value min equal to input, and have another value max equals input, but not yet. We actually have to do this after. So if we did it now, input isn't defined yet. So we need to actually move these till after we get our first value. And we'll move this comment as well. All right. So now that's the first part. The second part is that when we're processing in here, chapter 4.2 told us that if value is greater than max, set max. And if value less than min, set min. Okay, so what we're going to do, we're going to write that code. If, so value is the input. So if input is greater than max, then max equals input. Else if input less than min, and we don't actually need these because we're only doing single lines, then min equals input. I'll just go ahead and explain that. So in the book, and in general, it's always safest to put these in here. If you have a single line, you don't need them. But the problem is, what happens if I added a second line here and I didn't have those braces? That would be a problem. In fact, I've seen another bug that students sometimes do where they'll put a semicolon here. What happens if I put a semicolon there? Well, what happens is that semicolon actually ends the expression that's supposed to be executed. And then nothing gets executed. So it gets a little bit into details, but it's always safest to put these brackets here. Okay, I'll go ahead and add one here to be very explicit about what it is you're trying to execute. Okay, so, and then after I'm done with this whole while loop, now I have to actually print out. Let's see what it says. We want to say maximum was and minimum was. Oh, here, just grab both these. Let's put it down here. Copy this line, put it twice, and then put this over here, put this over here, get rid of these, and then I'm going to use string concatenation to be max, string concatenation to use min. All right, so what did we just do? We know this is a standard min-max algorithm. That involves, first of all, initializing the min and the max to be either the first or the lowest / highest value. In this case, we've already got a value here, so we can initialize that right here to that first value. Now, if you didn't have this loop and a half solution where you do the half loop up here, that would cause a problem for this because you don't have a first value. So you actually have to then use, you have to look up the Java value for the lowest possible integer and the highest possible integer, which is a common thing we do in other languages, but this half loop, loop and a half, actually makes it simple to do this. All right, and then inside the loop, we check to see if the value is greater than the max or less than the min, and if so, we set those values, and then we're going to print them out at the end. I know there's still one more bug, but let's... Okay, so we almost got it right. We got it right, we got it right, we got it right. So we didn't get it right here. And the problem is that if -1 was the first thing, then it specifies actually doesn't specify, but what it tells us here is your output should not include the minimum and maximum. Okay, if -1 was the only value ever entered, ever entered. Okay. Well, I guess they're just being very legalistic. It says once the number -1 is typed, it displays the minimum maximum that the user entered. And since the user didn't enter anything, it shouldn't display those. So what we have to do is we have to add in one more check. We have to check to make sure that the value isn't -1. The input, right? Because if it's -1, that means we never got into the loop at all. The first value ever entered was -1. So, well, actually, we could have done it. We could do it in two places, but this is as fine as any. So, if input doesn't equal -1, we're going to put that there, that there. Now, you notice that this is actually the same check as up here, but it's a different thing. We can't just throw this into that loop because we actually needed to do all of these first. Okay, so now what's the problem? Problem is we're not displaying it ever at all. Okay, so if input doesn't equal, sorry, actually input's always going to be -1. What we want to check is to see whether we ever change the minimum and the maximum. So any value other than -1 is going to change the maximum. So we could just put max. There we go. And that's also why you couldn't, I was just saying you couldn't bring it up there. Well, the reason why is there's a couple of reasons. It's a different thing. And it's a different thing because it's a different test right there. All right, so let's review what we've learned here. Sentinel min and max. There's actually two different things going on here. One is it's a sentinel loop. Two, it's a min and max problem. Okay, so for the sentinel loop, what do you have to remember? For the sentinel loop, you have to initialize some things. Here's some initialization here. Here's some initialization. Okay, then oftentimes, but not always, you have to do the loop and a half solution, where you print out that first value, and then in the loop you do the reverse of the expected order. So the expected order was that you were going to prompt first and then process the value. So instead we're processing the value and then prompting. And the reason we have to do that is because we don't want to accidentally process the -1. What would happen if we processed the -1? Well, it would come in here, it would always set the minimum to be -1. So that's not what we want. We wanted the minimum value to be the minimum positive value. Okay, so we need to check whether input is -1 first, and that requires having a value to start out with. So that's why we do the half loop outside. Okay, now I'll come back to this in just a second. And then last thing, once we've in order to do the min-max, okay, we have to initialize the min and max either to the first value that the user gives you or the lowest/highest value. The loop and a half helps us by giving us a first value. And then to process the numbers, you just check whether it's greater than the max or less than the min. Okay, now I wanted to go back and talk about this loop and a half solution. Do all Sentinel loops have a loop and a half solution? The answer is no. It depends on what you need to do with the last value. So for example, I asked my students to do a blackjack program where you deal cards until you hit 21. And in that case, you don't actually want to discard that last card. So let's say you got a 10 and a 5, that's 15, and then you got a 6, that's 21, you busted. But, sorry, let's say you got a 7, that's a 22, you've busted. So, but you actually want to process that card. You want to show that the user busted. And in that case, you don't need to do this half loop first, okay? You can just have a single loop, a while loop, and you generate a card, and then you print out the card. You generate, or you process the card. You generate, process. That last card, you still want to process the card, okay? So, no, not all Sentinel loops need the loop and a half. Only loops where you need to discard the last value. That's where you need this loop and a half. Because on that last value, you don't want to be doing the processing. Okay, so if you've liked this video, please like and subscribe. My channel does have a complete curriculum for the Building Java Programs book, And I've got a lot of these practice it problems. So hopefully that helped you, and good luck to you.